Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 21st February 2023. The problem statement for today says fill the matrix. This problem is based on mathematical operations and BFS, and this has been asked in Oracle interview. Let's now open the problem. So first we will go through the problem statement clearly. Here it says given a matrix with dimension n cross m entirely filled with zeros except one position at coordinates x and y containing 1. Find the minimum number of iterations in which the whole matrix can be filled with ones. Note, in one iteration 1 can be filled in 4 neighboring element of a cell containing 1. Okay, so here the question is saying that a matrix is given of n cross m where only one initially only one coordinate, that means one cell is having the element 1, and we have to find the number of iteration in which the whole matrix can be filled with ones. And here it is given that in one iteration, that means wherever that one is present, we can fill all the 4 neighboring cells. 4 neighboring cell means top, bottom, left and right. All these can be filled with ones. That means all the neighboring element of that particular cell which is containing 1. So for example, it is given here n is 2, m is 3, and here it is saying that 1 is positioned at x is equal to 2 and y is equal to 3. So here this is with that n is equal to 2, so 2 rows are there, m is equal to 3, so 3 columns are there. So x is placed, 1 is placed at 2, 3 here. So in iteration 1, so wherever the 1 is present, so the neighboring cells can be made to 1. Neighboring cells means up, down, left and right. So in first iteration we will make this cell, this 0 and this 0 as 1. So it will become, the resultant will be this one. In next iteration, since we have got 1 and 1 here, so the neighboring cell will be this and this. So in next iteration it is made this one 0 1 1 and 1 1 1. So these two cells have been filled with 1, and now we are only left with this the first cell where it is 0. So in next iteration, since it is a neighbor of both of these, so we can easily fill this with 1. So here we can say that in 3 iteration, that one is the given one, and 3 more iteration is needed to convert to fill the entire matrix with 1. So 3 is the minimum possible number of iteration in which the matrix can be filled. Okay, so now let's look at the second example. Here it is saying that n is 1, m is 1. So it is containing only one cell, and 1 is also placed in one cell. So the output is 0, saying that we do not have to perform any iteration. It is already filled with 0. So now to understand it in a better way, let's go to some few more examples which I have created here. So I have taken one example where n is equal to 4, that means 4 rows are there, 1 2 3 4. M is also 4, 1 2 3 4, and suppose we are placing 1 at x is equal to 2 and y is equal to 2. So this one. So in the next iteration, what will happen? So for this one, this 0, left, right, up, left, right and bottom, these 4 zeros are the neighboring cells. So in the first iteration, we have made all those 4 cells as 1. Okay, so here all the 4 neighboring cells of this one we have made as 1. In the next iteration, all the neighboring cells of all these ones, whichever we have got in this first iteration, we will make 1. So here this is the neighbor of this and this, so it will be made to 1. This will be made to 1 because neighbor of this. This also will be made to 1 because it is neighbor of this, and this also because the same reason, the neighbor of this one. So in the next iteration we'll get 1 1 1 1 1 1 here, so 0 will be here, here and here. So in the next iteration, whatever ones we have got in the second iteration, all the neighboring elements we will make 1. So if you see that, then all these things will be this 0, this and this will be made to 1. Only the left element will be the left cell with the 0 will be the last one. So in the next iteration we can make it make this 0 as 1 because it is the neighboring element of this and this and this. So here we can say the output here it will be 4. So we have taken 4 iteration here. That's why the output is 4. But here we can see, so this we have done actually by filling it with ones. So but if we try to extract one formula out of it, then what we can do? See here, if we see this one where it is placed as 2 comma 2. That means x is equal to 2, y is equal to 2. Then if we try to reach the farthest end from this cell where the initial one is given, if we reach the farthest end, then we can say that we will be able to cover all other cells. See, since we are making in each step all the neighboring elements as 1, and now if we are reaching the farthest cell, if we are able to reach the farthest cell in some iteration, then we can say that we will that in all other direction we would have made that all the zeros to 1. So simply here what we can do, from this cell we can see, from this one we can see which is the farthest end. So we can see this is the farthest end, this is the farthest end. So how many more rows we need to cover? We are already in row number 2. We have to go to this farthest end is in row number 4. So we need to cover 2 more rows. And how many more columns needs to be covered for reaching there? 2 more. So here we can see 2 more columns we need to cover. That means we are initially at this one, this column number 1. That means column number 2. We need to reach to column number 4. So 2 more columns has to be covered. So if we increase our row by 2 from here, then we will reach this row. And similarly, if we increase 2 columns there, so we will reach this column. So here we can see what is the intersection point. Intersection point of this row and this column is the last element. So this is the farthest end. And how many more steps were needed? The number of steps to reach the farthest row plus the number of steps needed to reach the farthest column. So here it will be 2 plus 2, that only the answer 4 that we have got in all these 4 iteration. I'll try to explain it with another example. Here it is a much bigger one. Here I have taken n is equal to 8, that means 8 rows are there, and m is equal to 6, that means 6 columns are there. And I have placed 1 at x is equal to 4 and y is equal to 4 here. So here if we try to apply the same formula here, then we can see that which is the farthest end and for this one, which is the farthest end for this one. So the way to calculate this is that see, right now we can easily see that this looks more further than this one. So but here according to one, we have to check the maximum of the x-axis where the 1 is placed, and from that we need to calculate the distance from this row and this row. We will need to calculate the end from this row and this row. So whatever is the maximum we will get, that we will mark as the farthest x-axis. I hope this is clear. We have to calculate the maximum farthest axis out of these two. Which two? First one and the last one. So if I do this one, from this one, if I have to reach the initial axis, then how many more steps we need to move? 1, 2, 3. So here it will be, one option is 3. Next option will be, for reaching to this one, 1, 2, 3, 4. 4 steps are needed. So the maximum of these two will be 4. So now we have seen that x-axis, the largest x-axis, the furthest x-axis will be the last one. Similarly, if you look at the y-axis, then which is the furthest y-axis from this one? This column or the last column? So to reach the last column, we have to just move 2 steps. And to reach the left one, we have to move the 3 step. We have to move 3 steps. So definitely this one is the this first column is the farthest y-axis. That means farthest y-axis. So here we need to move 3. So we have got x-axis as this one, and farthest x-axis is this one, and farthest y-axis is this one. Which is the intersection point? Intersection point is this 0. So this we can say is the farthest one. And how to reach this one? That means, so simply we will add those things. Number of columns we need to move and number of rows we need to move. Number of rows is 4, and number of columns is 3. So 4 plus 3 is 7. So output for this will be 7. So I hope this is very clear. So we have to, again, I will explain for this as well. We have to choose from the cell where 1 is placed to both the side to see which is the farthest one. So wherever the 1 is placed, if we try to find the farthest x-axis, here it will be where the cell is placed at x minus 1. That means that many cells we need to move to reach to this end. And another option is wherever this cell is present, we need to subtract that row number from n. So it is placed at 4, and we have total 8 rows. So 8 minus 4 is 4. So clearly this is the farthest one. So we have to choose the maximum of n minus x and x minus 1. So whichever is the greater one of this one, that will be considered as the farthest end. Similarly, it will be for y-axis. That means for y-axis or the columns. Here it is placed at this one 4. So we need to see which one is the farthest one. This side or this side. How will calculate this? It is placed at column number 4. So to reach to the extreme left, we need to move 1, 2, 3. That means y minus 1. Y minus 1 step, that is 3. So first option is 3. Second option is the number of columns we have. Number of columns we have is 6. And where it is placed? It is placed at 4. So to reach this end, we need to move 2 steps. To this side, we need to move 3 steps. To this side, we need to move 2 steps. Which is the maximum one? This side, left side. So this will be our considered element for the calculation. So we will see that left column, extreme left column, is the farthest column. So here it will be 3, and similarly for whatever we have got for x, we have got 4. 3 plus 4, 7. That is the answer. So this only we will just try to write it in a code. It will be, the solution will be very minimal. That means in 2 to 3 steps only. So yeah, but we will be following this approach only. So let's try coding this. Int, first we'll calculate the distance x. What will be the distance x? It will be the math dot max of wherever it is placed, max of this one. We need to calculate the farthest end. So math dot max of x minus 1, which is this row, and n minus x, which is this one. So whatever value we will get, that we will consider as the farthest one. So math dot max of x minus 1 comma n minus x. So we have got that which one would be our farthest x-axis or farthest row. It will be either this one or this one. So we have calculated it with that max operation of this value minus 1. So we will get this axis, and whatever the number of rows we have given, if you subtract where the 1 is placed, then we will get the last one. So whichever will be the maximum, we will consider that. So similarly, we will calculate int dist y is equal to math dot max of, here it will be y minus 1 and m minus y. So here again the same reason. Here the 1 is placed at this location. So we will see which column is the farthest one, or which y-axis is the farthest one. So from this one we can see that if we move towards left, then it is 3 steps. Sorry. So it is 3 steps, and if we move towards the right, then it is at 2 steps. So which is the farthest one? 3 steps. How we will get these two options? Wherever this y is placed, it is at 4. 4 minus 1, that will be this 3, and 6 minus 4, it will be this 2. So the maximum of these two will be 3. So that we will get there as distance y. Then simply we need to return distance x plus dist y. So that's it, we are done with our coding. So here if we see, here again the funda is that if we try to cover, if you try to reach the farthest cell, that means farthest cell from this matrix, then if we are able to reach there, then we can clearly say then that all these elements, that all these cells will be already covered. See, because wherever 1 is placed, we are plotting, we are replacing 0 with 1 in all 4 directions. So if you are able to reach the last one, the farthest one, so all the closest one or the closer one, those will be automatically replaced with 1. So here in the first example, here we can see this one was the farthest end, so that end was reached at the last step. But if you see the closer ones was made to 1 initially. So I hope this is clear. So now let's try compiling the code. So here we can see we have got our output correct. So even we will even try with those custom 2 examples which we have taken in Notepad. So initially here we have taken 4 4 2 2, 4 4 2 2, and here how many steps we got? We got 1 2 3 4 4 steps. So the answer should be 4 here. So see, here we have got our answer as 4. We will even try with the second example. Here whatever we had taken, here it was 8 6 4 4. That means number of rows is 8, column is 6, 1 is placed at 4 4. Here our output should be 1 2 3 4 4 plus 3 7. So here the output should be 7. So here we can see we have got our output as 7. So now let's try submitting this solution. So here we can see we have got all the test cases passed. So we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.